When most people think of rings in space, they picture Saturn, wide, icy, and dazzling. But what if we told you that 3 other planets also wear rings? In this episode, we'll take you on a tour through the hidden ring systems of our solar system, starting from Jupiter and working our way out. Jupiter, the largest planet in the solar system, has rings that are almost invisible to the naked eye. Discovered in 1979 by Voyager 1, Jupiter's rings are made of dust particles likely kicked up by meteoroids crashing into its small inner moons. You can't see them in regular light, but through infrared imaging, like from the James Webb Space Telescope. A faint, glowing halo appears, wrapped tightly around the planet's waist. Then there's Saturn, the ring's superstar. Its rings are made mostly of water ice and stretch over 280,000 kilometers wide, yet they're incredibly thin, only a few hundred meters thick. These rings are constantly changing, shaped by Saturn's moons and gravity. They may look permanent, but scientists believe Saturn's rings are slowly disappearing, falling into the planet like rain. Next, we visit Uranus, the oddball of the outer planets. Its rings orbit vertically because Uranus rotates on its side, tilted over 90 degrees. Most of its rings are narrow and dark, made of mysterious material that reflects very little sunlight. These rings were discovered with Earth-based telescopes and later confirmed by Voyager 2. Finally, Neptune, the quietest of the ringed planets. Its rings are so faint and fragmented that they were nearly impossible to confirm. Instead of complete loops, Neptune's rings form clumpy arcs, uneven segments that may be held together by nearby moons. Voyager 2 gave us our first real glimpse in 1989. Each of these planets has a unique ring system, some icy, some dusty, some chaotic, some barely there. And while Saturn may be the star of the show, the rings of Jupiter, Uranus, and Neptune reveal just how diverse and mysterious our solar system truly is. You just have to look a little closer to see them shimmer. True or false, Neptune's rings form perfect circular loops like Saturn's. False. Neptune's rings are clumpy and broken into arcs, likely stabilized by nearby moons. Which planet's rings are easiest to see from Earth? Saturn. Fill in the blank. Saturn's rings are made mostly of blank. Ice. Fill in the blank. Jupiter's rings are best seen using blank imaging. Infrared. What causes Jupiter's rings to form? Dust from its moons. If a particle in Saturn's rings travels 840 kilometers at a speed of 120 meters per second, how long does it take to complete the distance? To find how long it takes, we start with the distance. 840 kilometers is 840,000 meters. Then divide by the speed of 120 meters per second to get 7,000 seconds. Finally, convert that to minutes by dividing by 60, which gives us 116.67 minutes of travel time across part of Saturn's ring system. True or false? All four gas giants in our solar system have ring systems. True. Fill in the blank. The rings of blank are narrow, dark, and tilted. Uranus. Which planet has rings that orbit vertically due to its extreme axial tilt? Uranus. Fill in the blank. Neptune's rings contain bright, clumpy, blank. Arcs. True or false? Saturn's rings are made mostly of metallic rock and carbon dust. False. They are primarily composed of water ice with some dust and organic material mixed in. A dust particle in Jupiter's ring moves at 17 meters per second for 2 hours. How far does it travel? First, convert 2 hours into seconds. That's 7,200 seconds. Multiply that by 17 meters per second to get 122,400 meters. Then divide by 1,000 to convert to kilometers, giving us a final distance of 122.4 kilometers traveled by the dust particle. Voyager 2 confirmed the existence of rings around which planet in 1989? Neptune. Fill in the blank. The planet with the most visible and complex rings is blank. Saturn. If a ring particle completes a 1,000-kilometer loop in 25 minutes, what is its average speed in meters per second? Start with the distance. 1,000 kilometers is converted to meters by multiplying by 1,000. That gives us 1 million meters. Then convert 25 minutes into seconds by multiplying by 60, which equals 1,500 seconds. Divide 1 million by 1,500, and you get a final speed of 666.67 meters per second. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, Brainy friends.